Hi, in this video, we will be learning how to conduct a chemical risk assessment. Before we start, let's get an overview of what a chemical risk assessment is and why does it matter. Chemical risk assessment is a careful check that answers three questions. What could this chemical do? Who could be harmed and how? What can we put in place so people don't get hurt? Doing a chemical risk assessment prevents injuries and illnesses, avoids fires and spills, keeps you compliant with the law, and helps everyone work with confidence. Let's walk through a simple, practical way to conduct a chemical risk assessment from the beginning to the end. Step 1. Make a list of your chemicals. Start by listing every chemical on your inventory you use or store, even small bottles and cleaning products. Write down the name on the label, where it's used or stored, how much you have and how often it's used. Get the GHS label and the safety data sheet, SDS, for each one. These are your main sources of truth. Example, acetone used in workshop A, 10 liters per month, daily use. Step 2. Understand the hazards. Open the SDS. Focus on these parts in plain English. Section 2. Hazard identification. Shows the pictograms, red diamonds, the signal word, danger or warning, and hazard statements, e.g., highly flammable, causes skin irritation. Section 3. Ingredients tells you what's inside, useful for mixtures. Section 7-8, handling, storage, and PPE, how to set up the job and what to wear. Section 9, properties, things like flash point, how easily it catches fire, or pH, how acidic to basic. Section 10, stability and reactivity, what to keep away from. Heat, sunlight, certain materials. Section 11, toxicology, how it can affect health. Example, acetone, a flammable, use away from heat, may cause eye irritation. Step 3, describe how people actually use it. Write down the tasks: pouring, mixing, spraying, brushing, heating, cleaning, waste handling. Note who is around: operators, maintenance, cleaners, visitors. Think about exposure routes. Can it touch skin or eyes? Can people breathe the vapors or dust? Could someone accidentally swallow it? Example, spraying disinfectant in a small bathroom. Possible inhalation and eye exposure, especially in poor ventilation. Step 4. Pick better protections using the hierarchy of controls. Use the controls from strongest to weakest. Aim higher up the list whenever you can. Eliminate. Do you need this chemical or this step at all? If not, remove steps. For example, swap solvent wipe for mechanical cleaning. Substitute, can you use a safer product or a diluted version? If so, then replace a strong acid cleaner with a milder one. Engineering controls, separate people from hazards. Use a fume hood, local exhaust, closed transfer, splash shields. Administrative controls, make work safer by how you do it. Training, clear SOPs, labels, doing high vapor tasks when fewer people are around. PPE, last layer. Choose the right gear for this chemical and this task. Correct gloves, goggles, face shield, lab coat or apron, respirator if required. PPE is essential, but it works best after you've tried to remove or reduce the hazard with the higher level controls. Step 5. Evaluate the risk with a risk matrix. A risk matrix helps you judge risk quickly and consistently. You can calculate risk using a risk matrix. A matrix shows likelihood on a 1 to 5 scale where 1 equals rare and 5 equals very likely. On the other hand, we have severity on a 1 to 5 scale as well, where 1 is minor harm and is fatal/major loss. Multiply likelihood with severity to get the risk score from 1 to 25. Then use the bands to decide action to take, such as low risk, keep current controls and monitor, or medium, improve controls and proceed with care, or high stop and add stronger controls before work. After you add controls, rescore to confirm the risk has moved to a safer band. Step 6. Plan for emergencies in the environment. Use the SDS to write clear instructions for first aid, Section 4. What to do for skin, eyes, breathing. Spills, Section 6. How to contain and clean safely. What PPE to wear. Fires, Section 5. Which extinguisher to use and special fire hazards. Also note where spill kits, eye wash, safety showers, and extinguishers are located. Protect drains and sensitive areas with trays and proper waste containers. Step 7. Consider special cases. Think about anything that needs extra care. Vulnerable workers. New, old, young, pregnant, or with health conditions. Lone work or confined spaces. High volumes or high temperatures. Incompatible mixes, e.g. or bleach plus acid. Contractors, cleaners who might be exposed without knowing. If any apply, add extra controls or change the plan. Step 8. Put it into action and train people. Put the controls in place. Ventilation, labels, storage, spill kits. Update or create simple standard operating procedures with photos if helpful. Train the team. What to do, what to wear, what to avoid, and where to find the SDS. Label secondary containers right away. An unlabeled bottle is a hazard by itself. Step 9. Check it's working and review regularly. Make sure ventilation actually pulls air. Check PPE is the right type and fits. Record and review incidents or near misses. They are lessons. Review the assessment when the chemical, process, equipment, or volume changes, or at least once a year. After pulling it all together, a risk assessment should look like this. Acetone, for cleaning parts in workshop A. Hazards, highly flammable, eye irritant. Tasks, small pours and wipes, 10 minutes at a time, twice daily. People at risk. Operators and nearby workers, inhalation and eye exposure possible. Existing controls, use in fume hood, bonding, grounding metal cans. No open flames, nitrile gloves, goggles, labeled waste container. Risk rating before controls. Medium-high, due to flammability. Added controls. Keep heat sources out of the area. Limit quantity at the bench. Add splash guard. Residual risk, low-medium. Emergency. Eye wash within 10 meters, spill kit at bench, CO2 extinguisher nearby. Next review, 12 months or if process changes. Plan for emergencies, document simply, train your team, and review regularly. Done this way, a chemical risk assessment prevents harm, protects health, and keeps you compliant in any workplace.